Are you gonna go first or last?
I'll go last. I'll let Danny go
Oh yeah,
first.
sure. A couple of slides.
I'm Danny. I work at Kitchener. I use Go day to day for our backend microservice stuff.
I'm Cameron. Work at Jero. We do with live video and data over bonded cell network connections. It's like 10 times more. That was our this spiel. I use Go and C++. Mainly C++ these days.
I'm Roger. I'm here for the first time. I work at ZenReach. I've been at ZenReach for 2 years. We mostly use Python and Go.
I'm Brody. I work downstairs on the 8th floor at Index Exchange. We're going to be hosting next month, so hopefully we'll see you all out there a few floors lower. I work a lot in Go, a bit in Node.js, unfortunately a bit in Perl. Doing a lot of highly optimizing Go code to handle large amounts of data.
The view's almost as good on the 8th floor.
Almost as good.
Mitch, I'm an engineer at ZenReach. The offices are there. Roger and I work at the same place. We use Go for a lot of stuff.
I'm Moses. I also work at Index Exchange. It's been a while since I've used Go, actually, but it's still interesting.
I'm Sam. I'm co-op at Index Exchange, and I'll be using Go for my co-op term.
Nice.
Cool. Shane, developer at Jero. I'm not using Go recently, but don't
I'm Daniel. I'm a developer at Keyfree Technologies. Currently working on some Go-related, web services at Jero. But yeah, been using it every day for the past couple months.
I'm Asama. I'm from Shopify. I've been using Go mostly for side projects, most recently trying to figure out Google for recreating my blog site.
I'm George. I'm interested in lots of technologies and I find Go interesting.
All right, my name is Jesse. I'm going to have the honor of presenting tonight. I have here a little bit of bio information. I'm what's called a core committer, which is really just a software engineer working for a company called Mattermost. I used to work with ZenReach, so I know a lot of the guys here, which is pretty awesome, including Osama back in the day. Rather than putting my email address, I'm a really big fan of Keybase, so I posted my Keybase handle. If you don't know what that is, you should totally check it out because it's pretty cool. And we actually run an instance of our Mattermost application. If you don't know what Mattermost is, it's basically an open source private stack alternative to Slack. So you can imagine there's different companies with different data retention needs or data control needs, and Slack doesn't work for them in that context. So our product comes in and plays a part there. But yeah, you can totally join prereleasemattermost.com and check us out.
Do you have cute release notes?
Do I have cute release notes? I don't think they're anywhere near as cute, but I'll take a note to that effect. By way of an agenda, just so you know what's going to be going on tonight, I wanted to talk a little bit about why I wanted to talk about Go Dependency Management. What exactly is Go Dependency Management? Why should you care at all about any of this? And then not knowing exactly where everyone is in terms of skill sets and just the nature of this kind of presentation, I thought it'd be neat to work through some of the language primitives that enable dependency management, especially the tools that we'll talk about at the end. Some common patterns. I wrestled a bit with this because there's lots of things that you could talk about, and I realized the more I researched, the less I actually knew about the topic. So you might have some other common patterns or questions that I encourage us to discuss as a group. And then we'll survey some of the tools available to us for tackling this problem. So why do I want to talk about Go Dependency Management? If you've used Go, you'll know by now that it's very opinionated. Excellent response. I kind of like that, actually. I mean, it saves a whole lot of time when it comes to code reviews now because you know the code is basically going to look the same for everybody because the compiler generally enforces that and best practices. So that's been pretty cool. And some of the design decisions, I mean, you sort of just get behind the wagon and you're like, okay, this is the way it is, and you get used to that. The way you have to write loops everywhere and you don't have the opportunity to write like a map function, for example, like that. That's just the way Go is, and you move on, and it's pretty cool. But there's two things that kind of drive me nuts about Go. You've probably experienced that. One is whenever I comment out a block of code, and then, of course, that commented out block of code use an import that is no longer used in that file. I can't compile the file until I go and comment out the import. And it's just like, oh, why can't they just let me do that in that one case? The other one was the need to locate my Go source in the GOPATH of the Go workspace. So that was like literally the first thing that totally tripped me up when I started working on Go, is I didn't understand the GOPATH. It didn't fit into my mental model at all. I really, really wanted my code to live at home, documents, projects, and then how my little organization of all my different languages was going on. But they wouldn't let me, and I'm like, and I fought with it. I tried symlinks, and I tried all sorts of things, and sometimes I thought I fixed it, and then I would find the tool that wouldn't work, and it was frustrating. And I thought, this is an area about Go that I know a little bit about, and I thought it'd be neat to learn a little bit more about some of the thinking behind this, and what's going on under the covers. We also recently did a migration of Mattermost from Glide to Dep. If you don't know what those are, they're tools for managing vendor dependencies. What's Glide? What's Dep? Why did we pick one over the other? Some of these things were not as fresh to me as I thought they needed to be, so I thought it'd be neat to talk about that. But literally the most exciting thing for me was this announcement, I think at the end of February, beginning of March, by Russ Cox regarding Vigo. If you don't know who Russ Cox is, he's a Googler. He's one of the original authors, worked alongside Rob Pike on the Golang technologies, and he's really been there from the very beginning, and he's had this long play sort of vision for how he wants things to unfold, and Vigo is that next step in that process. And just reading about the design that went into that and some of the things it's going to unlock in terms of power, in terms of flexibility, but also at the same time just how familiar it is when you sort of take the Go ecosystem as a whole. I'm like, let's talk about that, because I want to find an opportunity to play with it, see what's going on there. Okay, so that's why I want to talk about Go Dependency Management. What is Go Dependency Management? Well, for a completely useless definition, Go Dependency Management is the art of managing dependencies in Go. Nobody actually said this, that's why I quoted a fictional person, but I thought it'd be an interesting way of slicing the problem out, because there's two keywords here. There's obviously dependency, which has pretty well-defined term that we'll look at. But then this art, this aspect. If you're not familiar with Golang, or depending on where you're at in your skill level, a dependency is something for our conversation tonight is a Go package that is required for compilation. So in particular, we're not going to talk about operating system dependencies or the Go compiler itself, although you could technically call that a dependency in some sense because you need it to build your source code. We don't need it to run it. And then we're not going to deal with like non-Go dependencies. We're also not going to talk about CGO because I don't really understand how that works and I've never worked with it, but that's what it is. So really these are Go packages that you need in order to compile. And if you followed any of the history about Go tooling, I mean, it's kind of been a tumultuous ride to this point. Every couple of years there seems to be something new coming out. The set of tools out there, I think there was 19 at the last count, depending on who you ask. And there's an aspect to managing dependencies in Go that kind of resembles art in some sense. Good art takes time and takes a long time. You need to be patient, but the final work is something that is, for a lot of people, is amazing and beautiful. But of course, it's also pretty subjective. I don't know whether Vigo is the final answer to this project, this artwork project, as it were. I'm kind of hopeful it is. I only joined sort of the Go ecosystem at the end of 2016, so I haven't been as jaded by the constant churn in tooling and what's going on behind the scenes. So a lot of this is still fairly fresh to me. But it certainly seems to require a certain degree of art to navigate all of this. Now, to be fair, if you're at all a JavaScript developer or not, this is just the normal way of development. Everything changes every 6 months, and Go is better than that in my opinion. So I think we should give them a little bit of slack. But this is sort of what Go Dependency Management is all about. Okay, so that's that. Now, why should you care about dependency management? Whenever you're wanting to build something, so make sure that's readable, there's a couple of things that you want to make sure your code can accomplish, or your build system can accomplish. You want reproducible builds. The idea here is that somebody else can follow the same steps that you prescribe to get the same binary generated at the end of the day, bit for bit, ideally. You want a certain sense of determinism in the sense that if you build the code tomorrow or from another computer in your house kind of idea, you get the same result after every single time. And then this is challenged sometimes in our environment of everything being in the cloud, but you want a sense of reliability from your build system. You don't want GitHub going down and then you're being unable to build your code, much less deploy your code to production, which is scarily a reality for a lot of environments. You certainly don't want the code disappearing from the internet altogether and then suddenly you realize that you have to rewrite this module because you never managed your dependencies properly. This is a real thing that's happened. I mean, you may have seen this earlier back in February if you sort of follow Hacker News is often my source for these kinds of things, but the author of Go Bin Data deleted their GitHub account and then someone else created a new account with the same name and pushed that same repository back up. What do you do at that point? You're just like, oh, okay, everything still compiles, it's all good. I would be paranoid. A lot of people were rightfully paranoid. How do I trust this code? Who knows what's going on here? What happened to the original author? Was this a ploy? If you manage your dependencies properly, this shouldn't bother you, at least not immediately. You may have to deal with it at a later point. You may have also remembered a bigger incident in the Node ecosystem a few years back with left pad. That may be a trigger a more emotional response, maybe slightly less useful code, but a similar kind of situation where the repository was deleted, or I think it's the Node package module repository, whatever that was, got deleted. So I think you ought to care for some of these aspects. I certainly care about it because I'm interested in this topic in general, as it were, and we have sort of a sense of what's going on here. So what I want to do next is, this is not a talk, in my opinion, that lends itself to be like, look at this nice code that I wrote. So I want to, show it off, as it were, to you. But I thought, I have to write code at a tech talk, as it were. So I thought I'd try to write some stuff. It's going to be very basic, but hopefully we'll learn some stuff along the way. Okay. Let me get my notes so that I'm not making something completely up. All right, so we're going to write the classic Hello World program. Just for context, I'm in, make that a little bigger. Is that legible to everyone for the most part? Okay. I'm running Go 1.10. I'm on OS 10 for that matter. And I'm just going to create a directory in my home path. I'm not setting much up here, and I'll tell you a little bit more about that later. We'll call it the Tech Talk. This is going to be a classic Hello World kind of situation, but to switch it up, I'll see if I can use the log library that Go provides. All right, let's see. I think it's log.print, hello world. All right, yeah, can't write code in front of people, clearly. There we go, okay, that looks about right. Seems like my editor didn't complain at me. I'm just gonna go run main.co. Cool, I got hello world. Now, maybe that surprises you a little bit. It shouldn't, but I didn't put that code in my GOPATH, which I thought was kind of cool, because that's kind of my goal here in life, is to get rid of the GOPATH, one of those things that drives me nuts. What's going on there? Now, your development environment might look a little prettier, but Vim's pretty cool too. What's this log package that I'm depending on? I can jump to that, and I can see here that this particular file is located under user local seller go 1.9.3, which is slightly different, but libexec, and then there's this source/log/log.go. So this, if you're familiar with OS 10, we generally install things using Homebrew, unless you don't use Homebrew, in which case you use something else. But I can go to this directory, go into the source directory, and lo and behold, I'm basically browsing the standard library that's provided with the Go compiler. You've all used this 1,000 times, I'm certain. Here's the FMT package, and I can open up print.go and find the print line. There it is. Well, that's not it, but there's print line. It calls a bunch of other functions, kind of idea. So at a very basic level, we understand that the import directive can know about the standard library that's included somehow magically with the Go compiler, and it resolves that, and it can compile the resulting binary that we want to get. So that's cool. Of course, I don't know of a lot of people that write only using the standard library at the end of the day.
Why not? What else do you need?
That's fair.
It's the Go way.
It's the Go way, yeah, write everything yourself. And in particular, I don't know of a lot of people who use just one package for their application. Usually the program gets a little bigger and it needs to be organized into different packages. This is not a talk about how to organize your code into packages. There's some good paradigms to be adopted there. I'm going to throw them all out the window and create a completely superfluous package just to demonstrate something. We'll call this one names, and call it random.go. My thing doesn't do anything helpful here. Let's import the math rand library, as well as we'll need time so we can initialize it. Whenever you use rand, you ought to remember to seed it, otherwise you'll get the same results every single time because it's deterministic otherwise. So Let's see if I remember this correctly or not. Time.now.unix nano. Okay, and then I'm gonna write a names array. All right, so remind me of some of your names here tonight. Just throw them out here.
Brody.
Brody, like that?
Yep.
Okay. Sam? Jim, Osama, good enough for now. Oh, Moses, I can't forget Moses. It's not gonna file, okay, pretty boring. Let's write a random name function, returns a string, and we'll take the ran.int modulo length of names. If I did this correctly, I think this probably is obvious to everybody, but all I'm really doing here is I'm defining an array. Thank you.
Also extra comma string.
Cool. This is really basic code. I'm not trying to show off any coding skills here, but just to make sure we're all on the same page here, I defined an array of strings. There's a function I've defined, random name, that's going to pick a random name from that array and return it. And just to make sure that the random system is initialized, I don't have to remember to do that in some other part of the function. I'm using the init function, which will get called automatically at the time when the program starts, and it seeds it with the current timestamp. All right, let's see how that works. Keep in mind, I'm still not in my GOPATH. So the question is, how do I use this? I mean, I want to write something like, what do I call it, random name? So let's change this. I think it's printf for log package. Names.random name. Okay, this part surprised me. That works. All right. Now, just out of curiosity, maybe it's not, it's perfectly fine to everyone. Did you know you could write relative import paths in Go? I didn't either. I thought that was kind of cool. Why would you want to do that? It's an honest question. You can't use this for production code. Well, I mean, you could. There's nothing really preventing you from doing it, but you generally don't want to use this for production code, right? Because they want you to work out a GOPATH. If you start compiling stuff, you'll find that, you know, when you're outside of the workspace, things aren't being compiled, aren't cached.
I think go build that.
Yeah. Oops. And Moses, what are the odds? It largely works as you would expect. I can't go install it. You'll see, no install location for directory tech talk outside of GOPATH. So there are some limitations in that sense. But otherwise it works. It's great for sandboxy kind of demos where you have a little more complex demo that I'm trying to set up tonight kind of thing. You could probably imagine a workflow that used this effectively kind of thing, but the problem is you're going to run into with any kind of weirdness is that if it's not idiomatically written according to the way people write the language, right? You don't want to put sentences together in English that don't make any sense to people just because you're trying to be clever, although the compiler accepts it here. You really want to try to do things idiomatically so that people are familiar with it. So this is great for demonstration purposes, but it kind of also explains why stuff like GoDoc works. And a lot of the Go tooling accepts relative paths, and it sort of fits into that, oh, okay, that's how it all works under the covers kind of thing. And there's my fantastic documentation for the names package. You should write better. Okay, so that's like depending on your own packages, as it were. Obviously, we generally tend to depend on third-party packages. Let's replace the built-in log package with log.rs. Ironically, we considered log.rs at Mattermost and ended up converging on something else for performance. But
so something, if I can interject,
absolutely.
something interesting about this specific logging package is there used to be a capital S
I
in the
was
GitHub
actually going to bring up
in the
that
GitHub
exact
username,
thing.
and the author changed that, and it broke a lot of builds for a lot of people.
Wow.
That is interesting.
Degero being one of them.
Index exchange being another. Yes, there was a week when we had to go through all our code and change all of the uppercase S's to lowercase S's.
Yep. Interesting.
And that was our first wake up to the fact that our production builds are completely dependent on push to the GitHub accounts.
Yep.
In real time.
Yep.
Because we use like some people, you know, if you do a go get on your local machine, well, you're safe, but we use Docker containers.
Okay.
These Docker containers do go get at Docker container build time. So literally every time you build a container, it pulls a fresh copy.
That's exactly what I'm hoping to demonstrate now, because I kind of knew this, but I didn't think about it, was what happens when I go get something. Hopefully this is what interests me. So let's do this. Let's replace, actually let's give logRS an alias so that I don't have to write too much code. I think it's info f, and then just because finish greeting. Oops. Okay, so you can see Vim's already complaining at me, but let's try to compile it anyway. Go run main.go. Oh, can't find package, GitHub, syrups, and logRS. Okay, let's look a little bit at the output here. You can see the path to user local seller. That's the Go route. That's what we found in the standard library before. So clearly it tried to look there but couldn't find it. I'll make that even a little bit bigger if I can, because I don't need a lot of width today. It also searched two different paths here. One was the user's Jesse, my name being Jesse, my home directory being user/Jesse Go, and then it also searched users Jesse/documents/Go. Let's take a look at the goenv and grep for GOPATH. So I set this up intentionally, but something else I didn't know is that GOPATH works just like the path variable if you're used to Unix, and you can have multiple GOPATHs, colon-separated ones. And it works kind of like the way you'd expect. It will search the first one, and then if it can't find it, it'll search the next one and keep going in that sense. Much like if you have a colon-separated path variable, you can have binaries located all over the place and just run it wherever you want, and it'll find it in the right place. If you go get, it always puts the installed packages into the first entry in your Go path. So there's some interesting things you can do with that, which we'll talk a little bit about later. So let's go get GitHub. Now just to show you, there's no Go directory at the moment. I haven't actually created that Go path. Actually, I deleted it right before this talk because I wanted to test everything. But go get logRS. It's clearly doing something. Okay. And we'll just see if it works. Okay. Doesn't output my other logs because I have to turn on the log dot, I forget what it is. You know?
Set level.
Log dot debug level? Okay. There we go. Okay, just to complete the demo. Okay, so now it's clearly found the code and compiling. Let's take a look at what's in the Go directory. And I'm not going to talk about package. You can go research that for yourself. But the source directory, I think that's what I want. Interesting. So we've got a structure here that clearly recreates the folder structure of the Golang package import paths. Clearly there's the logRS that I installed, but there's also this crypto and sys package, which I didn't install. Go get is going to get dependencies. That kind of makes sense. If I go into here and just sort of make sure that that makes sense, if I ag for crypto, okay, good. So you can see this file depends on Golang x crypto, and it's hard to ag for sys here, but you can see it's dependent there, golang.org x sys. Okay, so that's cool. Go get got, that's cool. A bunch of dependencies, but just to make sure we're all on the same page here, what exactly did it do when it went and ran go get? This, if I do a find, you'll notice it's a Git repository. And if I do a git log, depending on how you're set up here, you'll notice that I have the full history of the logRS repository checked out into my Go path, and at the moment it's pointing at master. So go get literally just went downloaded the master branch of whatever this repository was. This is getting at the heart of dependency management and why it's kind of a big deal. If your go gets are fetching master, you can just imagine the kind of problems you can run into. You know, you go get, and we ran into this all the time at ZenReach until we fixed it. You go off and run go get, and your CI build suddenly breaks because they decide they're going to change something in the package upstream, and none of your code, all your code in the local repository in your workspaces is compiling fine, but the new version does not. Or GitHub goes down, which unfortunately it has to do from time to time, and suddenly your CI servers are failing because of course it's dependent on fetching that. How do we fix this? Well, the language provides another primitive that's fairly important, and that is the vendor directory. And this is where my relative import paths start to fall down, but I'll do it anyway because it's kind of cool. The idea with the vendor directory is that you can, we saw the Go root and it searches the Go paths, colon-separated kind of idea. Well, you can put yet another search path or series of search paths in front of that by basically saying before you go to any of those other outside places, look inside the vendor directory. It'll look inside the vendor directory that's a sibling, so like in this case, vendor being a sibling to main.go, anything inside vendor would satisfy a package before anything outside. Then it'll search actually all the way up and the question is how far does it search up, to see ancestor siblings, which are kind of like uncles and granduncles in the directory hierarchy, to see if their vendors satisfy the constraint. So let's just like move this reps and logrs library. Actually, don't do it that way because I'll have to recreate it. I'll just move GitHub right into vendor. So now go source GitHub. The Golang is it's not even there in the Go package anymore. Let's see if this runs. Okay, so it doesn't like it. That's unfortunate. Doesn't seem to work. Make sure actually I didn't do something silly. I was expecting a different. Not in vendor. I was expecting a different error message. I wasn't expecting it to work at all, actually, but it's supposed to spit out this really nice error message that says you can't use vendor while you're using relative import paths outside of the Go workspace. Give me a second to see if I can remember why. That's not going to be there. Okay. Yeah, okay, I can't remember what it is. That's cool. The reason for that is because otherwise it doesn't really have a known point at which to stop searching for vendor directories, right? You're just sitting outside of the workspace. You'll keep searching up to your home directory, to the root file system, and then who knows what your code's doing at that point kind of idea. The way they sort of scoped that is by saying, if you're within the Go workspace, it'll search up to the top of the Go workspace, and then it'll stop. So it's kind of a self-contained system for managing that. So I can't use vendor in there. We'll see if actually this uncovers the problem. But if I move my tech talk into the Go workspace, Go source, you notice that I literally just copied the files in here. One of the other things that seemed magical about Go Get was this sort of directory structure, github.com, and there's like paths under there. I'm like, oh, is it somehow like magically aware of how Git works? And in fact, it does use Git internally. But at the end of the day, it's just paths to files. And so you can literally copy whatever code you want into your Go workspace, and assuming you reference it by the import path you created, it will just work. Now let's see if that makes any sense. Oops, go run main.go. Okay. So now it can find that vendor strategy, even though logrs is still not in the main Go package anymore. And if I wrote a different example test program kind of thing, I could demonstrate that for you. Okay, so that's that. Let's go through that just by summary again. Language primitives, the import directive knows how to search for standard libraries. Pretty obvious. You've used encoding JSON a lot, I'm sure, in your lifetimes. You can use relative import paths. You can go up and down the directory hierarchy, kind of like you might want to in lots of situations, but it's not idiomatic. It breaks a bunch of Go tooling, and there are certain restrictions like Go install on vendor directories that don't work inside that. So it's really just for sandboxing or playgrounds kind of situation, at least at the moment. Go get clones master. So keep in mind that unless you manage your dependencies properly, you're going to end up with a master branch of whatever dependencies you rely on when you install your application. And then there's this concept of vendor directories. And vendor directories can be nested. There's good reasons not to nest them. But in principle, they can be nested, and you can have your dependencies themselves have vendor dependencies, and it can go on indefinitely in that sense. That creates an interesting problem when it comes to what is the canonical way to refer to a Go package, right? Because in order to refer to a Go package, you need a path to that package. And two packages with exactly the same code but different import paths are not compatible. You can't just, the Go compiler doesn't just like, oh, well, it's exactly the same thing, so you can totally use them. They're completely different packages. So you end up with a problem where some of your dependencies might import, package A, but having vendored it, other dependencies, or maybe your application itself imports a vendored package A, and now you have two of the exact same package. It's actually compiled into the binary. It creates binary bloat, and the two aren't compatible if for some reason you had to like pass something from one to the other kind of idea. They will not accept that. So there's solutions to work around that kind of problem as well. And then there's this hierarchical import resolution. Search your vendor hierarchies, keep going up till you get to the top of the Go path. And then take your Go path, split it into colon delineated strings, and then search those left to right kind of idea. And then, of course, there's the Go root itself for the import paths. Does that all familiar, make sense to everyone kind of idea? Sort of know what's going on there? Cool. Okay. So what do we do with that? This is where the common patterns comes into play. See if I missed anything. So at this point, you technically have all the tools that you need to get reliable, reproducible, and deterministic builds that'll insulate you from the next Go bin data catastrophe or whatever comes out kind of next. So the couple of questions that sometimes come up when, how do you stitch these things together to manage your dependencies properly? One of the ones is, should I check in my vendor directory or not? I hope it's fairly obvious that if you choose not to check in your vendor directory, then you have to fetch your vendor directory from somewhere. Some of the tools we have later can do that for you and download the dependencies on demand. And they can download the, using lock files, the exact version of the dependencies that you want, depending on how those tools were written. That helps you with reproducibility, assuming two things. One, GitHub is still up. If it's not up, but you can't get the code. And two, you trust Git commit hashes, which I think we generally all practically do, but there's that whole SHA-1 kind of problem that's outstanding, and we're going to upgrade the commit hash, and who knows whether someone could find a way to exploit that if you were targeted by someone with high acting power kind of thing. So, checking your vendor directories. This isn't quite as painful as checking in node modules if you do JavaScript development, in my opinion. Node modules are just so huge. They often have platform-specific code that gets compiled when you do an npm install. So like all that pain, generally speaking, doesn't apply to checking in your vendor directories when it comes to managing dependencies with Golang. Another thing would be, how do you end up depending on something other than master? So again, this is not necessarily using a specific tool that helps you generate that vendor directory, but like literally, if I just wanted to do that, how would I do it? One option is literally just clone the repository. It's just code. Check out the commit that you want, whatever commit that is, and then copy that into your vendor directory and call it a day. Right? That's all these tools are really at the end of the day doing in some form or another. They're helping you build up that vendor directory. There's another cool tool, and it's just neat when you go through all this, how everything kind of stitches together at the end of the day. This guy contributed this idea to the Go ecosystem, and this guy contributed that, and then this sort of vendor directories came out of this guy's proposal, and it sort of all converges towards something. GOPackage.in, I can open up the link here if I can. I don't know if you've used it or not, but the idea is that it exposes conceptually these stable APIs for the Go language. And what it does is it offers a different import path that allows you to reference a particular either commit hash, usually a tagged version or a release version on GitHub or some other, I don't know if they support other repositories or not. But the idea then is when you reference that package through GOPackage.in, which is this third-party service, they're going to return back to you the code at that release version. And then your path to it is kind of like GOPackage.in / some reference to the repository, and then something like a /v1 or v2, which references one of these release versions. This is going to come up again when we talk about vgo, and it's so familiar. It's just like, this is beautiful. This is how it should have worked in the first place. I have a timetable later in the chart, but I think this came out in like 2014 as a solution to how do I manage all of this if I don't, depending on how I want to check in my dependencies kind of idea. So check out gopackage.in if you want to. If you don't want to actually just want to run on master all the time or whatever you check out at the time you build. Another common question that I find comes up is how do you manage local changes to upstream? So one of the cool things, I think I mentioned this already with way that GoGet actually fetches the entire Git repository, is that you can quickly go into there and start debugging code. Exactly when did this particular line of code get introduced? You can go and git bisect while you're in your GoPath, figure out what's going on, and then after you've made your changes, go and run your application, and it'll resolve that modified dependency and compile it, and then you can test to see, oh, okay, it was that commit that broke everything for me, and then file an issue upstream and complain to them kind of idea. But sometimes, the fix doesn't come forthwith. You need it now, and you can't wait for them. So a lot of times, what we do at Mattermost, and I'm sure a lot of people do, is we end up forking the repository. At this point now, we have total control over the code in our repository, and we can just check that code out and put it into our vendor directory, and away we go. This GORP library has kind of been stale for the past few years, so we've ended up making some of our own changes on it to support our particular use case. You add it to vendor. And an option, and I mean, there's a lot of, again, opinions about this, but you could totally, if you conceived it, check out this fork as a submodule in your Git repository. Again, if you're not using Git, some of this doesn't apply. Some people don't like it, and that's totally fair. I still kind of like the idea of submodules. They feel cool and clean, you know what I mean? Like your code's not actually in the repository, but it's still part of repositories you control kind of idea. So if you trust that GitHub's not going down, you probably need GitHub to get your source code to build in the first place, so your other source code doesn't really matter. And then things are clean, but it can break some tools, and developers don't often know they have to check out submodules and things like that. But again, this is all up to you, right? The language provides these very basic primitives, the vendor directories that you can use to override how dependencies work, and then how you choose to organize those files is a separate discussion in some sense. It's up to you. There's nothing terribly magical that's going on here. So this is the one that I'm still passionate about, is how do I avoid putting my code in GOPATH? And the real answer right now is that you don't, unfortunately. Don't symlink. You can, but just don't do it. If there's anything I can speak for developers everywhere, don't write a makefile that rewrites GOPATH to do its own sort of version managing system. It does work, you can make it work, but then your developers have to remember that they can't run Go test anymore. They have to import that GOPATH properly into their environment. And then sometimes certain search paths in Go test don't work, and it's just I just want to use the idiomatic expressions I've come to grow and love about Go, but I can never quite remember what the current flavor of the day is. Just give up that battle and put your code in GOPATH, and generally things work much, much better. Except that one of the key promises about vgo is the idea that we can get rid of GOPATH altogether, which is what we've wanted all along. So that may be an option going forward as well, and we'll take a brief-ish look at that at the end of our talk. And then the last one here, and it sort of came out from that discovery that you can have delineated GOPATHs, is that, how do you avoid cluttering GOPATH? I don't know if you've ever bothered to look at what's in your GOPATH on your developer machine or not. I mean, I don't know how most of that stuff came from. I'm assuming most of it came from my work development kind of thing. But maybe I installed some Vim tools that required Go tools, and they put their stuff in there, and now there's other stuff in here. Maybe you care about this and you want to figure out a better way of organizing it. I came across this blog, ironically from 4 years ago, so clearly some of this hasn't changed in a long time, but he has a cool pattern where he ends up separating out where GoGet by default puts stuff, so you can safely do a GoGet, and if you don't like whatever happened, just blow that directory away and move on, to organizing a Go personal directory and then a Go work directory. And then he can promote packages between them by just literally moving folders around, but then he cleanly isolates sort of what that GOPATH is, and you could conceivably sort of, remove part of that if you didn't want it to apply to a build in that sense. So that's one option, as it were. This might be a good time just to stop before we move on to some of the tools and say, are there any other kinds of patterns that you guys have run into, or questions that you've answered? I can't promise I can answer them, but things that come up when it comes to using some of these language primitives to manage dependencies?
So one thing that our company did when we worked with Node was you can set up your own NPM.
Yep.
And what I was trying to figure out is how to do that with Go. And you just mentioned two methods to do it. One would be Go package, sort of a third-party thing.
Yep.
Another one would just, we have our own Git stuff, so why not just clone it in there, or fork it in there?
Yep.
And that's the way you can control your dependencies.
Without having to check in vendor kind of idea. Yeah. It can be a little painful to clone everything you depend on in some sense, but sometimes that is also powerful because you have total control over it at that point.
It won't go down when GitHub goes
That's true, yes. Yeah. Assuming you're not using GitHub.
Unless you're also forking into GitHub, but we have an internal Git server.
Got it. Yep. GitLab or something like that. Yep. Anything else?
What's the packet.json.lock equivalent of this? So
We'll get to that sort of in a second when we look at all the tools, but unlike the Node ecosystem where there's kind of just NPM and Yarn duking it out for the most part, there's been a lot of people duking it out. The current sort of production tool is Dep, I think it's pronounced, which is what we migrated to, and it has a similar concept to a lock file. I don't know, this is totally off the Go trailer and whatnot, but I can't figure out what's going on with package lock these days. I don't know if you've experienced this with Yarn and NPM, but it's rewriting my package lock. I thought the point of a lock file was that you would install the things in the lock file or fail to do it, but never touch the lock file unless I upgrade something. And Yarn and NPM are both doing evil magical things with my lock files, and I can't figure out, I hate magic. Right? With every code, I hate magic. I want to get to the bottom of something so I understand it, and I haven't really spent the time, to be fair, but can't get to the bottom of what in the world is going on with Node. This is part of why I like Go. It's possible to get to the bottom of what's going on with Go. There's not a lot of magic between you and the operating system. So don't ever be like, I don't know how that works. Just get to the bottom of it. And I speak specifically to the co-op student in the room because sometimes new technologies can seem magical. This one is very much not.
This isn't really a question, but as long as you're just taking a little pause, I'll elaborate on a story that I think you will benefit the rest of your talk to hear a production example of
Cool.
how dependency management burned us. So you mentioned Logos.
Yep.
And last summer they changed the name from a capital S to a lowercase s. Was anybody burned on January 4th by math./bits?
No.
So Go 1.9 has a new built-in package math/bits, which didn't exist in previous versions of Go. Logos and Ginkgo both import sys/something from the Golang's own GitHub, like x/sys/some, I don't remember the exact package. And they made a commit in there, which now added math/bits as a dependency. So any Go 1.8 or earlier code that was trying to import either Logos or Ginkgo would fail.
Yep.
Within the course of the weekend, they made a change on there where they copied the one function from math/bits they wanted directly into the package and removed the import with the statement of, we have to support Go 1.8 for a few more weeks. We are now, Go 1.10 has come out, so they no longer have to support Go 1.8 anymore. They haven't repeated that change, but they could now repeat that change under their contract of supportability at any time they wanted.
Interesting.
For those that don't know, because we actually had a hard time finding it out, they support the last two versions. So as soon as 1.10 came out, they no longer support 1.8. As soon as 1.11 comes out, they'll no longer support 1.9.
It's interesting because they're violating Go's sort of paradigms for package backwards compatibilities. And
But it's outside of the standard library of Go. The backwards compatibility promise is only in the standard library, which is why we even live in a world where the authors of Go itself have a GitHub account where they publish extra standard library code, because everything in there is not bound by the backwards compatibility promise.
You're absolutely right that it's not bound, and certainly there's nothing to force anyone from bounding it. Part of the Vigo proposal is to encourage package maintainers to abide by this, which is pretty exciting on some level. Maybe that would help teach them not to do that kind of thing in the future, but yeah, interesting anecdotal story. I didn't know about that one.
This is a slight side note about the Go package.in.
Yeah.
And this also kind of relates to Vigo, but like everything really depends on people adhering to Semver rather than anything else. And it's like Semver is essentially a promise, right? Where it's like you promise not to break your code by adhering to the major version number increments for any broken changes. And you know, this is for a little library I was using called goa.design, which has like a code generator basically. And the code generator, like I was using gopackage.in, pointing it to v1, therefore making my code rely on the major version 1 for GoAgen. But it broke because they introduced a breaking change and they didn't increment the major version number.
And generated code no longer matched the library.
And it's like, it's nothing you can really do because gopackage.in unfortunately doesn't allow you to like zero in on a version any more than the major version number, which sucked because it was just like, well, I gotta upgrade everything, there's nothing else. Like there's no other choice. And I hope Vigo has a solution for that other than like,
there's no good,
because
basically the binaries that come with the packages, there's no good way of managing them.
Right, yeah. That reminds me, Jim and I are sort of sharing mutual grimaces of pain because we burned by the same package, but I think for a different reason. We had vendored Goa, so that should have protected us from that. But all the developers had gone and gotten Goa, and so their Go generation tools were different, and every time they ran it, it would generate different code.
Yep.
And of course, that code sometimes wasn't compatible with the library that we had vendored, and we were just scratching our head out like, why is this breaking? You know, eventually, we just sort of started using the vendored version of Goa to actually generate the code, which again was an awkward and artificial hack that was introduced by our not having put the code in GOPATH in the first place, because you know, there's the developer GOPATH and there's the one we manage by our build system, and so that's why we got why you should never do that in the first place. But yeah,
I had everything in the GOPATH. There was no escaping that.
you know, no, you're right.
Couldn't run from
There's nothing. I think vendoring is the only solution
Yeah.
to that, and
Yeah.
fortunately, that does still exist in the Vigo model. So let's look briefly then. Yeah, Dimitri.
I mean, you mentioned it at some point, but still to make sure that we very clear about logic here. So
Yeah.
you mentioned that let's say that there is some nested vendoring, right? So there's a package that also has its own vendoring.
Yep.
Right? And so let's say that there is a package that's imported by the target, by the thing that you're trying to compile, right? And it's vendor. But then there is one of the dependencies.
Okay.
Also has its own thing rendered. So what's the Go compiler gonna do in this case? So is it actually gonna compile a separate version or dependency?
If I followed the map correctly, yes, you'll end up with 2 copies of that package. Unless there was a loop somewhere there, in which case it either won't compile because they're different package paths.
So my understanding was that at some point that if the path is the same and you have 2 conflicting versions within the vendoring directory, then it's going to just refuse. And
Yep.
it's going to ask you to explicitly like figure this out so that it's just one version for compilation. Is that not always the case, or was
Only if I think they come into the same context of being used. As long as, you know, the way that they're used sort of never collide, it's totally fine to import the same package 1,000 times, as long as they don't ever try to relate to each other.
okay?
But that's my understanding, at least, from it. Okay, so then I promised you a survey of some of the tools. If you have a chance to go and read the Vigo series of blog articles that sort of explain the philosophy behind, you know, what Russ was thinking about in terms of writing all this, and he goes into a lot of the backstory behind some of the tools, which is a neat place to glean some of this kind of information. But way back before I was born, relatively speaking, in Golang time, there was this go install thing, which got replaced in 2011 by go get, which we all know and love and hate. And then, you know, some people immediately jumped on that. I forget his name. I should have written it down, but so these 2 different tools came out, GoVan, and then was later replaced by GoDep, which was an attempt to recreate what we now know as the vendoring strategy, and it did so by, you know, manually munging the Go path. It would kind of like, if I understood it correctly, it would check out your Go path into a local directory, and then before you built, you could like push your checked out versions back into GoPath so that it would all work correctly. Sort of as a manual way of doing that, if I understand the tool correctly, but it's deprecated, and it points to the next sort of like, don't use this tool now kind of thing. 2014 was when gopackage.in came out. And then, interestingly enough, the author of GoDep and GoVen, he worked with, I don't know if it was Rob or Russ, but that his ideas became the vendoring strategy as part of Go, which is kind of like a neat story of just sort of success. If you have an idea and you sort of fix something in the ecosystem, it may end up being part of the language primitives proper. And once vendoring was in place, then there was this huge explosion of tools. Well, I think vendoring should work this way. And then there was like Glide and GoVendor and GVT and GoVend and Vendetta. Vendetta was cool because it used submodules, and I still like submodules. But it billed itself as the Go dependency tool for people who hate Go dependency tools or something like that, which I thought was clever as well. A lot of these tools, I mean, I'm not surveying them all. There's just no point kind of idea. I don't know whether they're still actively developed or not. Glide was certainly one of the most recent ones in our sort of cultural history. But even Glide says today, you know, you need to go and migrate to Dep. Dep is sort of the thing to migrate to. What is Dep? Dep is the official experiment, but not yet the official tool. At least as of, you know, prior to February this year, it seemed like it was on the way towards gaining victory and eventually would kind of get folded into the actual Go compiler proper, and then there wouldn't be this external tool. It would just be part of how Go itself managed package versions. Then, of course, Russ announced the vgo announcement, and that kind of threw a curveball at the Dep team, and so there was some confusion there. I'm not going to go into how to use Dep. You could go read that for yourself, and you may already do it kind of idea. But it's kind of cool. One thing you can do is generate a dependency graph. This is our Mattermost server. I can move that out of the way just to see a kind of idea. But yeah, it just spits out all the data structures that it knows from inferring all the dependencies, and then pipes it to GraphViz to get something useful. Interestingly, the way Dep deals with all that vendoring nested directories is that it refuses to nest vendor directories and flattens everything. So you end up with exactly one copy of a package at any one time. And this creates some complexities because if you imagine all of the semvers that maybe some libraries assert or don't assert, there's sort of this complex solution that needs to be arrived at to figure out what is the right version of this package to actually use here. They said it was okay to use between 0.1.5 to 2.0.0. We're okay with that kind of idea. But this one said, a different range, and you end up trying to converge on the right version of that package. And there are actually, I believe, cases where there is no correct solution to that graph of dependencies, as it were. What do you do in that case? You end up needing to basically split the package and import it a second time at the version you want and give it a different name so that it doesn't collide anymore. This is sort of part of what led to the vgo proposal, and I can't do the vgo proposal justice tonight. There's just a lot of really cool concepts, but a couple of things that stood out to me, mostly because they were so familiar. And again, I encourage you to go read this in its entirety. But one is this import compatibility rule I'll talk about in a second. Two is a new concept, sort of, called Go modules, semantic import versioning, and finally, and there's a bunch more in the ... that you should read about, but no more GOPATH eventually. So what is the import compatibility rule? And this was alluded to before when it comes to the Go standard library, but basically this law, if you want to call it, if an old package and a new package have the same import path, the new package must be backwards compatible with the old package. Now, it's very easy to break this if you're not careful, but if this is sort of your mindset, you're going to fix it if you end up breaking it by accident, and you basically sort of realize that a major version of your package being released, it needs to behave backwards compatible. What does that mean? You add new functions, you don't remove them, you don't change the arguments that a function takes kind of idea. I would argue, correctly, I believe, that you shouldn't change the semantics of a function. I mean, if you keep the function the same and the same arguments, but does something completely different, you've broken backwards compatibility. People should feel comfortable using your package if it adheres to the same import path kind of idea. If it doesn't adhere to the same import path, the right thing to do is to create a new import path. And so this is where vgo introduces the concept of semantic import versioning. I'm skipping ahead because my brain's out of order, but that's okay. So just like we saw with the go package.in proposal, which is kind of sort of folding back into vgo, now there's going to be this awareness of versions, kind of, major versions in the path to a particular package. There's a little bit of magic going on here in that you could totally break up your Git repository and actually put v2, v3 as folders, and that would all work beautifully. But go get, or vgo get in this case, would actually be aware of the fact that it's talking to a GitHub repository, and therefore then know how to look up what are the release tags, and then it can infer what is the latest release of this particular major version, and then it will go and fetch that when you ask for v2 or v3. Just to keep things simple, if v0 and v1 don't have explicit paths, so you can just use the package entirely as it is, and you'll arrive at that version. But the idea would be that if you need to break backwards compatibility, you should release a new major version, and your users of your package will end up needing to choose consciously to upgrade to that next version by changing their import path. They'll never end up with your new code by accident. We do that all the time at Mattermost, actually, because we have a lot of people who depend on our code kind of idea. So we have to really be careful about when to bump the major version and get rid of all that cruft that's been building up that we wanted to get rid of all along the way. We just didn't have the cycles to do it. So you guys know about that. And then there's this concept of a Go module. And again, this is super familiar. It's a group of packages that share a common prefix, the module path, and are versioned together as a single unit. Most projects will adopt a workflow in which a version control repository corresponds exactly to a single module. And I haven't thought really deeply about this, but basically any Git repository you have right today that exports a Go package for someone else to use, usually in that case, even if it's yourself, is already a Go module in that sense. You need to annotate it in a certain way, very easily, but the concept is very familiar to us, right? We might have a whole ton of packages, and people might choose to pull out a specific package if they're depending on it, but we generally organize it into repositories that map nicely to this concept of Go modules. So with these sort of three things combined, I don't have any slide to demonstrate this, but I wanted to see if I can actually make it work, because demos are cool. I do have a random Go library of my own. I don't know if anyone has ever heard of Moneywell. I always like to find if anyone uses this really old tool kind of thing. Anyway, great financial management tool. Released a long time ago, got sold to some guy after the owner went to Apple, and then kind of got stagnated along the way, hasn't seen much development, and I use it all the time, but it's not getting new features, and I wanted to find a way to programmatically interface with the data, so I wrote a Go tool. I've tried multiple times before to write a tool to sort of model the SQLite data that's inside the application, but it wasn't until Go came along that I actually got it done. So I since then, I've always envisioned Go as a get-it-done kind of language. I don't know what it is about Go, but that's what I like. So again, I'm outside the GOPATH here, and I don't know if I remember all the commands, but we'll find, let's do clone here. Actually, that should work. Okay, so I'm in here. I believe that I have to touch this go.mod file, and I think it gets changed afterwards, but I'll go into my command directory, go into Mattermost, oops, doctor. Ugh. There we go. And there was another magic command. I actually need to install vgo, because of course it's not part of, it's not yet the actual compiler, so it's installed just like any other package. Okay, we can see it in the home directory. Or not. Okay, don't worry about that. Let's see what happens. Vigo build. Okay. So I have some dependencies. My particular project is not using any vendor dependencies. It really should have, and I think I have a branch where I was going to do that, but I hadn't gotten around to it. So we have Vigo actually going out and figuring out exactly what versions to use. Right now, it's very similar to Go Get in that it will fetch the latest version of the package, assuming you haven't specified any other constraints on it. And what's cool is that this is not going into my GOPATH. This is, well, actually, technically it actually is going to the GOPATH. It's going into this sort of like special temporary directory that Vigo's reserved for itself in the GOPATH that it's using as that, but I didn't have to manage that GOPATH. I don't ever have to think about it in the future. Okay, so that worked, and Moneywell Doctor runs, and I'm not going to prove to you that it actually does things. It does work, and that's the correct output when I don't provide a file. But essentially, what I have here now is a self-contained workspace that contains just my project. It's the Go module, and in fact, it rewrote go.mod to sort of this somewhat new syntax here to identify the module. This is the path at which it's located, and it inferred this from essentially the. Actually, I don't know if I can remember exactly how to answer that, but there's a way to infer that information, and then here's its statements about exactly what versions it depended on. So I'm dependent on the GoSQLite 3 and the errors package in that case. I can do stuff like.
So the module will make sure that everything under your Go Moneywell project is using the same version.
Yes. Yes.
Is that like the relatively log file?
Yes. So.
But it only uses Samver rather than commit hashes?
Correct. So if you want full reproducibility, you do need to check in the vendor directory for all the good reasons we talked about. And Vigo supports vendoring at the root only of your Go module. It doesn't respect or honor any vendor directories anywhere else. It's all managed at the root, kind of like how depth flattens things. Well, now it's flattening it in one sense all the way to the root of your project. But then the interesting thing about this, and it's hard to demo with my project. It's better if you follow the tutorial, but it converges on the minimum version required, which you need to sort of follow through the math here, as it were, but it ends up being able to, you can prove that you can always arrive at a correct solution if you honor the Go import compatibility rule, in that you know that the major versions are always compatible. So the code to actually resolve the dependency hierarchy is way simpler to reason about. It's not nearly as complicated, it's not going to fail in weird sort of ways. And by default, this will never go up unless it absolutely has to, kind of idea. So you're not going to be forcing people always to go towards the latest version of your package. They're generally going to be sitting at the version they got when they set things up in the first place. I can do a few things, and again, I haven't used this extensively, but you can sort of list the modules that you're dependent on, kind of idea. And I can actually, I didn't realize this until today, but I can actually now vendor those dependencies, and now I have the confidence of, nothing's going to change these dependencies going forward. So it vendors more than what I'm dependent on, you'll notice, because it's actually downloading Testify, which is a test assertion library that I love and use all the time. And that's part of my unit tests. We would need to vendor that in order to run the unit tests. But it wasn't, formally speaking, part of the Go module because it wasn't needed to run the Go module. It's also fairly intelligent. I mean, I think they're all intelligent in this way. But if your code imports a package, but only uses part of that package, it's not going to vendor and resolve all of the packages that package may have imported if you did like a full recursive search through it. So it's only going to vendor the sort of the slice of the universe that you actually need to compile. All right, so now we should have a Venn directory. It's a little different than the Venn directory you've come to love and observe. And here's your Vigo list, which kind of looks a little bit like the running the Vigo kernel in the first place. Again, semvers here, but I don't care anymore because it's checked out, right? This is the code that I want. It's going to be committed when I'm done. And at this point now, everything, I'll go and see if I can run a different one of my other commands.
So obviously Vigo is like replacing the top level Go program.
Yes.
It's like a fork of Go and
Precisely. It implements everything Go does plus this new functionality. And if the proposal continues the way it's supposed to, we'll probably see a release. It's optional, and then they'll force it upon us in the release after that, and we'll all have to accept that this is the new Go way.
As Go.
As to now, here's a case where either I don't know how to use the tool yet, or something is broken because it's very much in beta. I thought I could just go into my other command directory and do a Vigo build. No, wait, I ran Go before. It does work properly. And now I have Moneywell CLI. Again, it's running the same thing. So now, that thing that I was super annoyed by at the beginning of my talk with the GOPATH thing, I don't need to do that anymore with Vigo. I can put my code wherever I want, and like we've always kind of secretly wanted to, but just adhered to the system because we were told that was the Go way. Our code can live anywhere, and you can just compile it the way you want to. I don't know where Vigo fits into everyone's sort of timetables. I don't know. We're probably not going to do anything about it at Mattermost right now just because we just switched to Dep and it's still new and uncertain. But you might have some sort of additional repositories that contain load testing code in our case or something where it's not as critical to work in the same way. So I'd encourage you to go and try this and then provide feedback. This is the time. Maybe, I'm too young, I don't know if that's the case, but not often in my life that I've been able to be involved in something as it's happening, if that makes sense. Usually I discover a tool or technology well after it's been immortalized, and now it's just, that's the way it is. But now's the chance you could probably change something about Vigo if you had a really cool idea or it didn't work for you. So get involved, go try Vigo, and that is the end of this talk, except for any other questions you might have.
What is your specific problem with GOPATH? It's an environment variable that's tied to a process effectively. You can have multiple.
Yeah.
You can point them to different locations unless you're sticking everything in one /go directory.
Yeah.
Like that's the source of the problem. What are your woes here?
This is true. Until I learned that I could have colon-separated GOPATHs and could have lots of them, I didn't know that there was a solution to this. And so the conventional thinking had always been, just move your code out of wherever you normally locate it on your disk, whatever fancy structure you have, and put it into the GOPATH. With the colon-separated, I could see how you could just continue to add every single Go project you want into the GOPATH, and it would kind of sort of just work, except keep in mind that there's this scanning order that would happen. So if you wanted, you're going to be, if you're using the same package as one of your other projects that's also using the GOPATH and maybe earlier in the chain, you're going to use that package before the one that you put in your GOPATH. So you can never truly isolate things, and it's kind of I have never seen anyone use GOPATH except for that blog article that I referenced in that way before. The conventional way is, everything goes in the GOPATH in some sense.
Well,
But
if the GOPaths are pointing to two separate, like you have two different shells, don't. If you have two different GOPaths,
Yeah.
like two different shells,
yeah, okay,
you have one GOPath that's pointing to one,
right.
one going to another tree. But
Yep.
The worlds are isolated. Right?
This is, you're absolutely right. You can totally do that. And a lot of times you'll see that built into Makefiles where they'll redefine GOPath for that purpose. I just find sometimes that that's irritating as well, and maybe I'm being really nitpicky. That's totally true. But if I go and go test into that directory and I don't have the right GOPath, it's not going to work. So I have to figure out what the magic here is, and then I get to use my tools.
I'm the same way where it's like I just hate the fact that I can't just put all my files where I want to put my files and have to put them wherever all Pike says I should put my files.
Resist authority.
Formatting your code the way Rob.
Well, yes, actually.
So there's still no practical way to split your code amongst multiple repos and have them all independently vendor things, use each other's vendor packages and stuff.
Right, so if you split them into different Go modules would be the new terminology to split it up kind of idea. The expectation, if I understand it correctly, is that if you import a package, you're kind of importing a library, and libraries shouldn't vendor things. I'm not sure I 100% agree with that sentence, because it kind of feels like, well, no, of course I want my library to vendor things, because it should work this way. But if you think about it from a certain other perspective, it's like, why should every library everywhere get to force on me what versions of what packages I want? Yes, they should be able to assert things like
So everything you
paths.
regardless of how you organize your code, you end up with one vendor directory. That's sort of what you're saying. It resolves all of the dependencies.
Yes.
So you end up with one vendor.
Yes,
So you don't end up with this split vendor
correct.
compatibility.
So as a library, if you need version 1, you'll reference version 1, and trusting the Go import compatibility rule, version 1 will always work for you, so you don't care. And if V2 comes out, your library doesn't use V2. The path has to change to adhere to this rule, and therefore, if that top level project, whatever it is, starts needing to use V2, it can totally do that. It's a different package. So that's sort of the thinking here in that sense. Yeah. I'm excited by Go. I don't know. Everyone else is, but
Yeah, I read over the Vico proposal about a month ago, and I was really excited while I was reading it.
Yeah, I was just mostly happy about the lack of a GOPath.
I haven't downloaded it and tried it myself, but I read over most of the 8 blog posts about it.
Yep.
Kind of got lost during a couple of the more technical ones.
Yes.
But
There's some deep math concepts in some of them, but
Yeah, I skipped all the stuff when it went minimal version selection, so
Yep.
over my head.
Cool. Thank you for your attention tonight.